All right, let's get it. One take, that's all we need. We just took a look at this Musiclm generating music from text by Google. In classic Google fashion, they released absolutely no code for us. We have no way to actually verify any of these outputs. They did release a pretty big data set. Looks like it's got 5,000, maybe 6,000, depending on how you round it, music to text pairs, which may be useful for training. And maybe we can use some of the models that already exist to train and potentially recreate this. I'm sure that in the next 2 weeks, there will be some hero of magnificent proportions that will develop an open source version using this data. So I'm not, I'm hopeful. We're in the future. Every day, something new comes out. You can't really not expect progress. You really can't. So first impressions, I noticed that this does have that classic muddy output sound that all of these music generators seem to have. I'm not sure if that's a consequence of the kilohertz that they're using here, which it's not, because on Dance Diffusion, even if you go up to 96 kilohertz, 48 kilohertz, which is way above the range of audio frequencies that humans can hear. In fact, it's twice as much. So according to the Nyquist theory, that should be able to reproduce all of the sounds in the range of human audio capabilities. We still get that muddy sound. It still sounds like the output has been covered with a piece of cloth and played through a pair of poor quality headphones. And here you can take a listen and see what I mean. I don't know if you can tell, but there's that kind of fuzziness. It sounds like this if I could just fly through here. Like an old school 1920s speaker. It sounds muddy. That's what I call muddy. Doesn't sound crystal clear. The features that are of note are the text to audio. We had text to image to audio from Riff Fusion. We had audio to audio from Jukebox AI and Dance Diffusion. Here now we have text to audio using a similar model architecture to Jukebox AI, as well as I didn't say it was using a diffusion model. I think it was just using a encoder decoder structure with some semantic tokens and some acoustic tokens that seem to be combined to produce what we're looking for. And that's in the same realm of Jukebox AI, which was doing the vector quantized autoencoder, which is another form of tokenization. I'm not sure if this is using vector quantized autoencoding technology, but it definitely did mention a quantization as being a key component to the success. I'm not entirely sure what the exact model architecture is. I haven't done a full deep dive of this paper, but if people are interested and the views are high, I definitely will. But it is using some kind of tokenization instead of a noise removal process, similar to Jukebox AI. And the results are not much better than what Jukebox AI was putting out. And just to compare, here is Jukebox AI. I mean, that's pretty good. I'm not really hearing, it's not blowing, this new model isn't blowing Jukebox AI out of the water. So
Na 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 na. Na 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 na.
Those aren't necessarily lyrics per se, but that is probably the best feature of this. The text and melody conditioning, they are assuming that this is actually doing that. They're taking a melody that's known and they're adding a sound of the melody that they want, and you just heard that. They reproduced Camptown Races as someone humming, which is pretty crazy. And although the lyrics aren't actual words, a lot clearer than what Jukebox AI was putting out. So Jukebox AI was doing a pretty good job of producing actual lyrics that fit the music, but they were usually kind of muddy and hard to discern clearly without having the lyrics in front of you so you can read them and your brain will fill in the gaps for you. So here's the Jukebox AI's lyrics. I mean, Jukebox AI, this is by OpenAI. This was one of the best models that have come out ever, I think. This will be in the Hall of Fame. This is really good. But you can hear the lyrics are kind of hard to discern. But here, this, that's some of the clearest vocalizations I've heard. But since they didn't release the code, I don't know if that is just a selected piece of audio that was sounded the best. I'm not sure if there's a preset list of melodies that it knows, or if it's trained in some kind of LLM fashion to have a bunch of various melodies and maybe even inferring melodies based on previous data or something like that. I'm not sure what it's doing here, but this does sound pretty good. I think this is the meat. This is the good stuff here. This is better than anything I'm seeing. The continuations here, the long generation, although these are very long, in the paper they're saying that they're going with 15-second increments, which is about the same as what Jukebox AI was doing, and Jukebox AI takes about 6 hours to produce anything of quality. So it didn't give a time frame here, but I'm hoping that it is faster and able to do this pretty quickly. Let's see if we can find that. All right, so yeah, we advanced with a stride of 15 seconds. So these pieces I think are a couple minutes long. So if it takes anything more than a minute to produce these 15-second pieces of audio, we're talking about a significant amount of time. 10-minute range to give us anything that's 3 minutes long or something like that. So how good is this? I don't really know. Can't really tell. How good does it sound? Pretty coherent. It is pretty coherent, and it does sound like actual generated or composed pieces of music, if you forgive the muddiness that seems to be common with all these music generators. And another thing, so that you can tell, that's pretty coherent. That sounds pretty good. It is a little muddy, but I did notice that the tempo of all of these seems to be about the same. So let's go ahead and play this again. And then let's go ahead and play this techno here. It's about the same. And if we play them both at the same time here. So one's a little bit faster than the other. I think maybe the swing might be a little bit faster than or maybe the techno's faster than the swing, but they are pretty similar to the point that when you're playing them at the same time, it almost sounds like another new piece of music, which if they were truly extremely different, wouldn't be the case. You can't put on some Bach and then put on some Skrillex, play them at the same time, and they kind of fit together. It's not going to work. It'll sound like a complete mess of gobbledygook. So how unique are these? It's hard to tell. They give some generation diversity ideas here, or results here, and show that they are producing different sounds for the same text prompt, even different sounds for the same text prompt and semantic tokens, where the semantic tokens are just those additional pieces of information when something is tokenized that have respect to things outside of the actual data, like maybe the theme or the tempo or the whatever it is. It's going to be something that's not necessarily the notes or the actual audio being tokenized. They'll add an additional, for text, the semantic token might be a verb, like a semantic token that signifies that this word is a verb, or signifies that this word is a start of the sentence, or that this word is something that usually appears at the end of a sentence. So with the same semantic tokens and the same text prompt, it wouldn't be that out of range to expect the results to be extremely similar, if not the same, especially if we're using a quantized space where the representation of this data is being passed in through another layer of abstraction to something more generalized. But we can hear that they are kind of different from each other. So same text prompt, same semantic tokens. So they sound pretty similar, but they are kind of different. And here I think we can hear some lyrics. So although the lyrics aren't actual words, very coherent, much better than Jukebox AI at producing actual vocals that sound significantly different than the instruments underlying it. And I think that's a result of the AudioLM here, which you should also take a look at. This is pretty impressive as well. This came out, I think, in September, and it does a good job of continuing prompts, this is insane. I think this is honestly more impressive. So take a quick look at this just to kind of see. The AudioLM is used in this Musiclm, and I think they repackaged it and called it something slightly different. Perhaps the Mulan, or I think it is the Mulan. They kind of repurposed Mulan to be more music focused, but Mulan is based on the AudioLM system. So just take a quick look at this. We have
some images, like some sensations.
That's it. And then it's going to continue it at the 3-second point.
Some images, like some sensations, which produced by the light of nature in all creatures, are subject to various conditions, as in the...
That's very impressive. So they are using that, and as well as it looks like 2 other models to combine to get these new audio generations. So to wrap it up, I guess, because this is just the first look. I haven't gone in depth here. I haven't explained the paper. If this gets a lot of views, I will do that. But to summarize my first impressions, I would say the quality of the audio is pretty similar to the quality of the audio of Jukebox AI, which came out about 2 years ago. I would say the variety of audio is maybe a little bit more complex than Jukebox AI. We hear a lot of layers in these sounds here. So go back to this techno piece. That's pretty good. That's a lot of layers. It's pretty complex. That sounds like something that's ready for production if we forgive the muddiness, which I think is probably just due to the 24 kilohertz instead of 48 kilohertz. And hopefully they went with 24 kilohertz as opposed to 48 kilohertz due to the size difference. You shrink it in half. So, who knows how long this took to produce, but if you're going with 24 instead of 48, it's going to take half the time. Potentially. So compared to Jukebox AI, it's similarly set up. We're getting better, more clear vocals that are much more distinct than they would be in Jukebox AI. The variety of the audio, I think, is about the same, but the complexity, I think, is definitely higher here in terms of the amount of layers in a song with, it's got the beat and some melody, a couple melody tracks, and then kind of a finishing thing there. Pretty good. In terms of long generations, we don't have a time frame. So if it's going 15 seconds, Jukebox AI was doing about the same. It's actually a parameter you can set. I think a generation above, I think it was maybe 3-second generations, 3 times to give a 9-second generation would take about 6 hours. So hopefully these 15-second generations are maybe as fast as the Jukebox AI's 3-second generations. I don't know. The story mode here, it's okay. It does do a good job of changing the sounds as it progresses through. So time. So there were some vocals and lyrics there, not in English, but slightly better than Jukebox AI. Not by much, though. Overall, this isn't that much better than Jukebox AI. And since we don't have any time frame, we don't know how much this has been, how long these outputs took. We don't have any of that kind of information. We can't try it ourselves and try and reproduce these sounds. It's hard to really rate this. But that's just my first look here. And I got a Intel GPU that's still in the box that I will open up and take a look at. We have a bunch of models that need to be trained using Intel hardware with one of these challenges I'm doing. I've trained the YOLO model on the 3090 right now, and I'll do a YOLO explanation. I have a new starter for my truck. I got a 1986 F-150. Needs a new starter. I might post a video of changing the starter. Pretty simple. If you guys are interested in that. A lot of stuff. I got classes and stuff like that, so I'm kind of a little bogged down. So this is kind of just a ramble. My first thoughts, we'll see how this format gets appreciated. Just one take, putting out what I think. This new model that came out yesterday, I think it's okay. I don't want to be too optimistic because they didn't release the code. So if Google wants a good review, then they better put out some good code for us. I'm not sure what they're hiding the code for. They released a data set. It's not like they're going to be able to send this out to production to make money from it. So I don't know why they're being so secretive here. But it is what it is. Results are hard to really quantify. It did look like they had some quantitative measures for metrics here. Which I don't know how good these are. I'm not going to go into these right now, but these are just basic. I don't know how good these are really. So that's it. You guys comment, subscribe, let me know what you want to know. I can do a deep dive into this paper if you want. And it wouldn't be a problem. If this gets a ton of views, I will definitely do that. Please comment so we can advance each other's knowledge and become smarter, better, and more efficient. That's the goal here. We will improve and we will succeed. I hope you guys have a fantastic Saturday. Peace.